This is a review for the Edgenuity lesson, Simplifying Non-Perfect Roots. So I'm just going to show you a way that I visualize simplifying these that's a hair different than what they do in the video. So we're going to do this one last. So looking at this one here, we have the fourth root of x to the 9th power. So what I do when I go to simplify this is I figure out how many groups of 4 can I make out of this x to the 9th. So what that means is right now we have 9 total x's in there. It'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to create groups of 4 because we are fourth rooting. So it looks like I would have one group of 4 and another group of 4 and one left over. So I'd have one group of x to the 4th, my second group of x to the 4th, and then a lonely x by itself. Now, if you have the same exponent as the root, so the fourth root of x to the 4th, there's two ways we can think of it. We can write it out like this. And what happens is if you have fourth root of x to the 4th, they cancel, and it's just an x. They cancel, and it's just an x. This was to the first power, so it does not cancel. It is stuck as the fourth root of x. Then whatever you have out here in the front, you multiply it. X times x is x squared. Like so. Okay, so on this next one, if I split it, well, let's look here. If we have the cube root of 27, that's 3. It's a whole number, so that's nice for us. So cube root of 27 is 3. So I'm going to go ahead and pull that one out. And then we're left with the cube root. Okay, so a cubed. So that's great. We have a group of 3. Remember, we're doing group of 3s because this is a cube root. So how many group of 3s can we do b to the 7th? So there's 3, 6, 7 b's. So I'm going to do it a little differently than I did here, a little less work. So as long as it has a cubed, it essentially gets to come out of the radical. And as it comes out, you cancel out the cubed. So the cube root of a cubed is just a. That guy's taken care of. The cube root of b cubed is just b. The cube root of b cubed is just b. And then we have one lonely cube root of b left. And then from there, just simplify the part out front. So this is 3ab squared times the cube root of b. Okay, so on this next one, we have the cube root of 256 times x to the 10th power times y to the 7th power. So let's not worry about the variables. Let's just look at the number here for a minute. If I do the cube root of 256, I get a decimal. So we need to figure out what perfect cube goes into 256. So for example, 2 cubed is, I'm just going to make a list over on the side. 3 cubed is 27. 4 cubed is 64. 5 cubed, 125. So I'm showing you how you can find all these values. 6 cubed, 216, and we'll stop there. So we need to see, these are all perfect cubes. If I cube root them, I get a whole number. So we need to see if any of them go into 256. So 256 divided by 8. Okay, that works, but let's see if a bigger one works too, because you want to do the biggest one. So 256 divided by 27 does not. Oops, 256 divided by 64. Ooh, that works, and that gets us all the way down to 4. So I would choose this one. Okay, so what that means is we have the cube root of 64 times 4. That's still, because when I did 256 divided by 64, I got 4. So those are the two values I'm going to use. Now, how many groups of 3 can we make for x to the 10th? Because we're cube rooting. You got to pay attention to that number. There's 3 of them. 6 of them, 9 of them, and there's our last x for our x to the 10th power. Now for y to the 7th, how many groups of 3 can we make? 3, 6, and then the last 7. So there's 7 y's still and 10 x's. So for the x's, we were able to make 1, 2, 3 groups of 3, and for the y's, we were only able to make 2. So if I split it all up, oh, this is going to be hard to write. 4 times the cube root of x cubed (1, 2, 3). Oh boy, I'm going to run out of space. Cube root of y cubed, another cube root of y cubed, and then the very last cube root of y. Okay, so the cube root of 64 is 4. This one, the cube root of 4, we can't do. This one cancels and we get an x. Cube root of x cubed cancels, get another x. Cube root of x cubed cancels. And then this guy's stuck because it's the cube root of just x. Cube root of y cubed cancels. Cube root of y cubed cancels. And then we get this very last lonely cube root of y. So if I simplify all of these parts that came outside of the cube root, I have 4x cubed y squared. And see how these are all cube rooted? You can put them back together in one big cube root and do 4xy, like that. Okay, so on this last one, what I would probably do is whenever you have the square root of a fraction, you know they say to split it up and do the square root of the top and the square root of the bottom. If you can ever simplify the fraction, do that first. So I would simplify the 2/18 to 1/9. This simplifies to 1/9. So it just becomes x to the 5th over 9. So now, it's a little bit easier, square root of the top over the square root of the bottom. So on the top, when you're doing square root, there's an imaginary little 2 there that we don't write. So we have to figure out how many groups of 2 we have in x to the 5th. So that would give me x to the 5th. So I end up with 2 groups of 2, 2, 4, 5. All over the square root of 9 is just 3. So if it has a squared on it, it gets to come out. And this is just less work than doing it this way. And if it gets a squared on it, it gets to come out. But as it comes out, you're canceling out the squared. So the square root of x squared is x. The square root of x squared is x. And then we have that one last lonely x that has to stay behind. And then if I do my final simplifying here, we end up with x squared, square root of x over 3. Okay, and then the last one, again, if you can ever simplify, you need to do that first. So I noticed that 10/54, those are both even, so that's going to simplify to 5/27. And then if I have 5 x's on top and 8 on the bottom, we can cancel out these 5 as long as we take it away from the 8. So x cubed. The whole thing is cube rooted. So now we're going to do the cube root of the numerator over the cube root of the denominator. Well, lucky for us, the top there's nothing to simplify. There are none of these values are going to go into 5. So we have the cube root of 5 over the cube root of 27 is 3. The cube root of x cubed, again, those cancel each other out and you just get x. So that would be our final answer on that one.